Hello and welcome to another physics tutorial. So today we will be covering problem number 58 in chapter 13 about gravitation. Now what I want to say before I start solving is that this problem really needs you to know about two-star systems, which you should learn about by watching our previous video about problem 54. If you have watched that video, let's move on. So we have our not star system in this case, it's a star and a planet. So we have a star, the center of mass, and this planet. So they each do circular orbits. They aren't perfect circles, but I think you can see the picture. So we have R1, R2, total distance R. This is M1, this is M2. So we want M2 essentially and R2. Alright, so let's find a few equations. So first we can find gravitational force, which is g m1 m2 over r squared, which by centripetal force means that this equals m1 v1 squared over r1, as well as m2 v2 squared over r2. We can also do the period equations for both, so we get 2 pi r1 over v1 equals 2 pi r2 over v2. So first what we can do is find r1 by doing r1 equals tv1 over 2 pi. Now, we technically know t and v1, but they require you to look at this graph. So we can see that their label shows that our period from here to here is 1500 days. Now, they say line of sight velocity, which means that we can only tell the velocity going in this direction, which means that the maximum velocity on this graph will be when our star is moving in this direction, which means that it has a constant circular velocity of 70 meters per second. So we get that this equals 1500 days times 86,400 seconds per day times 70 meters per second all over 2 pi, which gives you that the radius of the star's orbit is 1.44 times 10 to the 9 meters. Next, what we can do is realize r equals r1 plus r2. So we write g m1 m2 over r squared, which equals m1 v1 squared over r1. We cancel an m1. And then we can now solve so now we can take our period equation, solve for v1, which equals 2 pi r1 over t, and plug that into this equation to get that g m2 over r squared equals 4 pi squared r1 squared over t squared, which all over r1, which simplifies down to 4 pi squared r1 over t squared. So if we move up here, because I'm running out of space, so we can see that g mt squared over 4 pi squared equals r1 times r1 plus r2 squared if we move some stuff over, including plugging in r equals r1 plus r2. So now we can plug in values to get, so we have a value for g, a value for m. So this is the mass of the sun, by the way. So again, we have our t, but now it's squared over 4 pi squared. And now we have 1.44 times 10 to the 9 for r1. And then we can do that again for, yes, plus r2 squared. It got a bit cramped here, but basically what we did is we plugged in our previous value of r1 into this equation. So now if you expand it and solve this quadratic, you would find that r2 equals 2.5 re. Alright, so from here we can find the other value we wanted, which was m2. So we set g m1 m2 over r squared equal to m1 v1 squared over r1. We can cancel m1s and solve for m2 by doing m2 equals v1 squared r squared over g r1. So if you plug in all your known values, which includes v1 is 70 meters per second, r is r1 plus this r2, and g and r1, of course, you should get that m2 equals 3.7 mj, which is the mass of Jupiter. Alright, thank you for watching. I hope you learned more about two-star systems with this video. Please like the video, subscribe to the channel, and I will see you later. Bye!